Here are the operational guidelines for BSL-1 facility. The first point comes is facility design, how the facility is designed. Like we have BSL-1 facility in our laboratory. So few important points are there. I have written this in very much detail, but the important point is the facility should be fully enclosed. There must be ample space to work. Wall, ceiling and floor should be smooth and easily cleanable. There must be adequate illumination. Bench top should be impervious. Laboratory furniture should be sturdy and open. Space must be there between and under benches. Storage space must be adequate to hold the supplies. The important thing is the wash basins. There must be wash basins in each room and they must be near the exit. Doors should be appropriate with fire rating. They must be self-closing and having vision panels to see the persons outside and inside. Although no specific ventilation is required, but there must be a mechanical ventilation system for to provide an inward airflow and exhaust without recirculation. There must be a specific drainage system. There must be specific spaces to store solvents, radioactive materials, and compressed gases. There must be the safety system for fire and electrical emergencies. There must be emergency shower and eye wash facilities in case of any accident. There must be a first aid area that must be accessible to the lab workers, and there must be a good quality water supply. Other than the previous facility, there must be a reliable electricity supply along with the emergency lighting. There should be an insect and rodent control system. There must be the facility for storing outer garment and personal items. And for eating and drinking, there should be provided outside the working area. No smoking, no eating, no drinking signs must be displayed clearly inside and outside the laboratory. Now, what are the safety equipments required for BSL-1? There must be the pipetting aids to replace mouth pipetting. The tubes and bottles must be having screw caps to avoid any leakage. There must be disposable pasture pipettes whenever available to avoid glass. Sterile plastic disposable transfer loops and spreaders must be there to avoid incineration of regular loop, glass spreader, etc. There is not a requirement of any specific PPE, personal protective equipment, for working in BSL-1 laboratory, but although one must wear the aprons and gloves, procedures are very common. For example, no eating, drinking and storing food is allowed. Touching body parts are not allowed while you are working with microbes. Wash hands after entering and after finishing your work, or sanitize your hands. Laboratory should be kept neat and clean and free of material. There should not be any cluttering. Work surface should be decontaminated at least once a day. Member of all staff should wash their hands after working before leaving the laboratory, and all work must be done in a manner to minimize the creation of aerosols, because most of the pathogenic microbes is spread through aerosols. Laboratory door must be closed while working. Children are not allowed in the laboratory. Now about the laboratory monitoring. First of all, there must not be any unauthorized entry in the laboratory. Only trained personnel are allowed. The workplace and the used instruments should be cleaned after working. No viable cultures are left unattended. They must be stored as per the requirement, and the work must be recorded in the notebooks or entry registers available in the laboratory. Now the waste management, there is no specific requirement on waste management in BSL-1 facility. However, guidelines of the Pollution Control Board must be followed. Any effluent from the laboratory should be pre-treated, and microbiological testing of treated effluents along with records should be available. Health and medical surveillance, although the risk group 1 microbes which are to be used in BSL-1 facility are non-pathogenic, but pre-employment health surveillance procedure must be there before appointing any lab staff. In the emergency situation, any accident must be informed to laboratory supervisor, and a record is also to be maintained. Here I am giving you one layout of a BSL-1 laboratory. This is very basic, used when handling agents not known to cause disease in healthy humans. So basically there is no primary barrier required, although gloves and lab coat is advisable and mandatory. You may work on open benchtop also. There must be a hand washing sink, and the sharp object must be stored in the specific boxes. Biohazard symbols must be displayed. Now BSL-2 facility. Basically we are going to handle risk group 2 microbes in the BSL-2 facility which may be pathogenic to human beings. So there are some rigorous guidelines for designing the facility. First of all, an autoclave for decontamination must be present in the same building, because so that you need not to take your lab bears or glass bears to other laboratory for autoclaving the microbe. So it must be in the same building. Decontamination facility must be in the same building. There must be biosafety cabinets, BSCs to be used, must be CCTV camera surveillance, and the biohazard warning symbols must be displayed. So the safety instruments, as you know now, autoclave must be there, biosafety cabinets must be there. Now about personal protective equipment. So the uses of laboratory coat, gowns or uniform is required to prevent contamination of street clothing. Goggles and face protection must be used. Face mask with appropriate gloves must be used. Here is detail about the gloves and how their gloves can be reused, how they can be disposed of, etc. All PPE should be removed so that transfer of infectious material to area beyond where they or animals are being handled is minimized. This means you need to wear the PPE or any other safety aid inside the laboratory only. Used disposable PPE should be disposed of. Reusable protective clothing should be laundered through laboratory laundry facility only. They should not be taken outside the laboratory. There are certain specific procedures for BSL-2 facility, like all contaminated liquid or solid materials should be decontaminated before disposal or reuse. Containers used to collect, handle, process, store or transport within a facility must be leak proof and have a lid. Laboratory coats, gowns or uniform should be worn in the laboratory only. They should not be worn in non-laboratory area. Safety glasses or face shield and other protective device should be worn to protect eyes and face from splashes and impacting objects. Specific persons, or if there is any requirement of immunization for performing any experiment, then that specific person should be allowed only in the laboratory. Needles and syringes should not be used as substitute of automatic pipetting devices. Never wear contact lens while working. Always add disinfectant to bottle wash while working with infectious substances. But need to use the sealed rotors or sealed buckets or the sealed tubes for centrifugation of potentially infectious microbes. All procedures should be optimized to minimize the formation of aerosols and droplets. And whenever required, but need to work inside the BSC only, biological safety cabinet. Leak-proof containers must be used. Packages containing viable microorganisms must be opened in a facility having an equivalent or higher level of physical containment unless the microorganism is biologically inactivated or incapable of reproduction. Only trained laboratory personnel or staff must be entered inside the facility, and persons working in the facility are not transporting the laboratory material including hazardous organisms outside the laboratory or with the wrong way of transporting it. And the persons working in the laboratory must be aware about the microorganism they are going to handle, and any accidental spill or splash must be cleaned immediately and must be reported. The waste management system, autoclaves and sterilizers for treatment of solid waste, and incinerators may need to be of a special design and equipped with the burners and smoke consuming devices. So there must be a constant health and medical surveillance in BSL-2 facility. Pre-employment health surveillance is necessary for all workers, and if required, a baseline serum of all laboratory workers must be stored. Then record of illness and absence should be kept in the facility in a register. It must be noted by the in charge. If the lab worker is a woman, then she must be made aware of the occupational hazard microbes such as rubella, cytomegalovirus, etc., which may affect the child carrying capacity of a woman. And here the layout of a BSL-2 facility is shown as shown here. Autoclave is present inside the facility. Biohazard symbols are there. Sink is there. Biosafety cabinets and fume hoods are there. And personnel must be gowned and must wear gloves and eye protection devices. In the BSL-3, the basic BSL-2 facilities must be present. In addition to these basic facilities, there are some additional facilities required as per the guidelines of the authorities and regulatory bodies, and these labs must be registered or listed with the appropriate national authority. Now the laboratory, the first of all, about the design, the laboratory should be separated from the area that are open to unrestricted traffic flow. So it must be at one corner of the building or at the blind end of the corridor. This means this facility must be separated from the common traffic flow. There must be double door system for the entry inside the laboratory, because RG3, risk group 3 microbes which are highly pathogenic are going to be used inside these laboratories. There must be an anteroom or airlock, and airlocks must be self-closing and fitted with seals at the top. Airlocks must contain viewing or vision panels. There must be physical mechanism for security system like interlocking or alarm system must be there in place. The surface of walls, floors and ceilings should be water resistant and easy to clean. A foot or elbow operated wash hand basin should be there to avoid the contact of the hands. Windows in the laboratory should be closed and sealed. So, as I told earlier, the windows must be closed and sealed. Now, the door of the laboratory should be self-closing and lockable. There must be an autoclave for decontamination of the laboratory waste. And very important thing, there should be a ventilation system that will maintain a negative pressure into the laboratory. What does this mean, negative pressure? Suppose this is the laboratory area and outside area environment is here, then the pressure must be higher outside and less inside, so that air will always go inside from the outside environment, so that there should not be any chance of any microbes or aerosol to come out of the laboratory. So to minimize the environmental contamination, there must be negative pressure into BSL-3 facility. The bulk area must maintain at an air pressure of at least 50 pascal below the pressure of adjacent area. This is very important. And there are certain other conditions. When one door is open, then two, at least 25 pascal reduced pressure must be inside the area of the laboratory. So these are few important guidelines for designing the facility BSL-3. Since windows are closed, so the air inside the laboratory area must be circulated through HEPA filters. The exhaust air from the facility must pass through HEPA filter and must be tested for by a qualified person. This means whatever air is going outside the laboratory, that must be passed through HEPA filter to minimize the release of any aerosol or microbe from the laboratory. So the complete air system is controlled inside a laboratory. The building exhaust system can be used for this purpose. One thing I wanted to tell you, there are HVAC systems, heating, ventilation and air conditioning systems. These are the big ducts. The whole plant is there which maintain the temperature, ventilation and air conditioning inside the facility. These are terminally having HEPA filters. The supply air and exhaust air systems are interlocked to ensure inward airflow at all time. This means whatever air that is going inside the room and coming out the room must be from different vessels. There should not be common passage like air is coming from this pipe and going from this pipe. If this will happen, then a constant airflow cannot be maintained. So there are different ducts for inflow, and the air raisers are there in the laboratory. They are kind of hollow pillars from where the air go outside the laboratory. The HEPA filtered exhaust air from class 1 and class 2 biological safety cabinets should be discharged directly to the outside or through the building exhaust system. Here is the link which can show you the facility of BSL-3. Kindly play this later on. The BSL-3 facility must have a designated area for hanging PPE. Facility must be constructed to enable gaseous decontamination. If it is required to decontaminate the whole gaseous environment of the chamber of the room, then the facility must be designed like this. There should be a liquid drainage system which is capable of inhibiting the entry of invertebrates or other animals. There must be a proper water supply facility protected against backflow. There must be separate supply for laboratory sinks, BSC, and autoclaves. The work area in the facility must contain IWAS equipment. There must be piped gas supplies. There must be shower facility. Before exit, this is very important, a shower facility must be available before exit. Appropriate areas should be available for donning and doffing. Donning means to put on the gowns or PPE, and doffing is to remove the PPE or laboratory clothing. There must be constant CCTV surveillance. There must be class 2 biosafety cabinets. There must be dedicated refrigerators, freezers and incubators labeled with biohazard symbol. Must be air-locked, autoclaved, etc. So in the PPE, there must be protective, solid front laboratory clothing worn by workers when in the laboratory, and they should not use this outside the laboratory. There must be a eye protection device inside the facility. There must be respiratory protective equipment, PAPR. I will tell you what is PAPR. That should be used if the microorganism has higher possibility of a spread through aerosolization. Gloves must be worn. There are certain specific procedure to work inside BSL-3 facility. First of all personnels must be trained, they must be responsible, they must understand their work and the sensitivity of the contamination inside BSL-3 area. The two-person rule should be applied, whereby no individual work alone within the laboratory. The first thing in the case, this rule is made for avoiding any accident. So there is thereby no individual work alone within the laboratory. Biohazardous materials must be stored in definite containers which are labeled particularly, and decontamination procedures are almost similar to the BSL-2 procedures. All biohazardous waste must be decontaminated in the facility or building itself. There must be procedures for disposal of biohazardous waste, including chemicals and radioactive waste, in consultation with the biosafety officer. And the regulations laid by national competent authorities for design and operation of facility handling radioactive materials should be followed. Medical examination is mandatory for all personnel working in the containment laboratory. Baseline serum must be stored before starting work in the laboratory. Employees either immunocompromised or being treated with immunosuppressive drugs should not be employed in the containment laboratories. This is the structure of BSL-3 laboratory. So here is the airlock system by a two-door. There are two doors, and here also constant airflow is maintained. Inside is the negative pressure. Biohazardous symbols are pasted throughout. There is shower at the exit, as I told you. There is also one ante room where The gowning is done. Now the BSL-4 facility. This is the facility where RG4 microorganisms, which are the most hazardous and toxic to human health, are used. And its construction and operationalization must take permission from competent national authorities. Now the facility design, the controlled access, that is the most important thing. Controlled access means the laboratory must not be easily accessible to the non-workers. So it must be located in a separate building. There must be security systems deployed like door locks, biometric authorized door locks, and the exit and entry of the personnel must be through airlock systems. An efficient primary containment system must be in place. There are two kind of systems in BSL-4 laboratory. One is cabinet room. Cabinet room house class 3 biological safety cabinet BSC, and it must be separated from outside environment by two air lock entry doors. Since RG4 microbes are being handled, nothing must be taken outside of the room. Cabinet room must be attached with outer and inner changing room fitted with shower. An arrangement of interlocked autoclave or fumigation chamber must be kept to transfer material inside the cabinet room. Another kind of room is suit laboratory. Basically, this is a protective suit laboratory is designed and maintained to provide personal protection equivalent to that provided by class 3 biological safety cabinet. Now try to understand. This means the whole laboratory is the BSC 3 cabinet now. A specific suit is worn by the workers, and this laboratory must be attached with outer and inner changing room fitted with shower. Entry into the suit laboratory is through an airlock fitted with airtight doors. Exit must be through a chemical shower facility to decontaminate the surface of the positive pressure suit. Everybody need to wear a positive pressure suit. As I told you earlier, there must be a negative pressure inside the laboratory up to BSL-3 and BSL-4 also. But in BSL-4, if you are working on a suit laboratory, then you must wear a protective suit that is having positive pressure. Means that suit will isolate you from the environment of the laboratory itself, and through a pipe, air pressure would be generated so that nothing can come inside the protective suit. I will show you the picture photograph of positive pressure suit later on at the end of this presentation. So that is always swelling like balloon. An appropriate warning system for personnel working in the laboratory must be provided in the event of mechanical system or air failure. Decontamination room must be fitted with the decontamination shower system attached with the suit laboratory. After the suit laboratory, there must be a decontamination shower system. A chemical shower would decontaminate your positive pressure suit. As I told you, the negative pressure must be there. Both supplies and exhaust air must be HEPA filtered. Design of ventilating systems for cabinet room and suit laboratory must be different as explained below. Now this is about the ventilating system. For the cabinet room, a dedicated non-recirculating ventilating system for cabinet laboratory is required. So a non-circulating ventilating system for the cabinet laboratory is required. The supply air to the class 3 BSc may be drawn from within the room through a HEPA filter mounted on the cabinet or supplied directly through the supply air system. Exhaust air from class 3 BSc must pass through two HEPA filters to release outdoors. The cabinet must be operated at negative pressure to the surrounding laboratory at all the time so that no microbe can come out of the BSc. Personnel must wear a positive pressure supplied air protective suit. There must be dedicated air supply and exhaust system. There must be a ventilating system to provide a definite direction airflow within the suit area from the area of least hazard to the areas of greatest potential hazard. There must be redundant exhaust fans to ensure the facility remain under negative pressure at all the time. This means facility is at the negative pressure and the protective suit is at positive pressure. Differential pressure within the suit laboratory and between the suit laboratory and adjacent area must be monitored constantly because one is using most hazardous microbes. Exhaust air from the suit laboratory must be passed through a series of two HEPA filters prior to release outdoor. And this can also be recirculated after being filtered through double HEPA filtration. But under no circumstances this exhaust air from BSL-4 should be circulated to other areas. So here are certain safety equipment which are almost same. Here we are using BSC-3. Personal protective equipment, one piece positive pressure suit, that is very important. And the laboratory practices, these are very stringent because you are using the most hazardous microbes or pathogens. So the PP is one piece positively pressurized HEPA filter supplied air suit. Air to the suit must be provided by a system that has 100% redundant capability with an independent source of air for use in the event of emergency. Means under no circumstances this positive pressure inside the suit must be hindered, otherwise this might lead to the health hazard to the workers. Before leaving the laboratory, personnel must pass through a chemical decontamination, as I have told you. The laboratory monitoring is like BSL-3 only, and the waste management is the most critical one. All hazardous biomaterial must be strictly decontaminated within facility within 24 hours. Transportation not allowed. Double door pass through autoclave is provided. I will tell you what is this double door autoclave. The autoclave is immersed or that is fitted in the door on in the walls. One is the inlet, other is the outlet. This is the autoclave that is fitted inside the wall only. So this is called a double door pass through autoclave. Decontamination of effluents must be done